we talked about electrolytes and non-electrolytes. We said the most important thing about electrolytes is the formation of ions or the presence of ions in the solution. If something cannot dissolves in water and cannot form ions in the solution, then we call it non-electrolyte. But if it forms ions in the solution, we call it electrolyte. An example for electrolyte were the salts or all the acids, are all of them electrolytes which they form ions in the solution. But examples for non-electrolytes are sugar or alcohol, the two types of sugar, which are glucose and sucrose. Now, we will leave everything about suspension and colloid. We will not talk about suspension and colloid again. We have to talk about solutions from now on. In the second section, we'll talk about the solution process, everything that is related to a solution, from enthalpy, from changing heat, everything, from the factors. Now, first we start with the factors affecting rate of dissolution. Right here means the speed that a solution will dissolve, or a solid will dissolve in a solution. We have three factors. We'll talk about each one of them individually and in detail. First, let's talk about surface area. Let's talk about surface area. If we want to increase surface area, there is one way to increase surface area, and that is by breaking down the solute, or making the solute into smaller pieces. All right, into smaller pieces. That's how we increase surface area. At that time, because the dissolution process occurs at the surface of the solute, and it can be speeded up if the surface area of the solute is increased. All right, a more finely divided a substance is, the greater the surface area. So if we more finely means smaller pieces. Let's see what these two notes mean. For example, this is a lump of sugar, a sugar cube. If this sugar cube, we put it inside a solvent, right? Let's move this one here. If it dissolves we put it inside a water or into a tea. The solvent will collide with it, will have a contact only in these areas, and it will gradually start to melt, or start to dissolve, sorry, not melt, to dissolve. But what if we break down this cube of sugar into smaller pieces? For example, let's break it down to 4 smaller pieces, like this. Now, before that, we only had contact on the surface of this cube. Now, we have contact from the surface of the cube also, and there are some surface areas which are increasing, and some solvents can also get into contact with the solid. Now, more surfaces are increased. We call this breaking down of a particle or something into smaller pieces, increasing surface area. At first, we only had these surfaces. Now we have, besides the surfaces of the outer part, now we have surfaces also inside. That's why surface area is increased. That's how we increase surface area. And this will help to speed up the dissolution process. It will become faster. It will dissolve faster. Why? Because the contact between the solvent and the solute is more. There is more contact at the same time, in a smaller time. That's why, for example, if you put a sugar cube into your tea, it needs more time to dissolve than to put the same amount of sugar as powder into your tea. كواتا قربيتو شكر بكوب خيت الناو شاكوا باشا خاوتر تويتو وقلو الشكر بباودر بكيت الناو شاكتو همان ئەماوەتی شەکل بکەتە ناو چاکەت لێرە چی ڕوویاوە لێرە surface area is increased. So at that time what has happened? We have increased surface area. How? By breaking down the subject or the solute into smaller pieces. So increasing surface area, is it inversely proportional or directly proportional? Of course, directly. Directly with what? With the dissolution process. With the dissolution process. That's the first one. That's the first factor. But be careful. Until now, we are only talking about rate, dissolution rate. We are not talking about how much solid can be dissolved. Only the speed, how fast a solid can be dissolved. How fast a solid can be dissolved. For example, as I said, powder sugar dissolves faster than a lump of sugar. And increasing surface area is directly proportional with the rate of dissolution. So we are talking about rate of dissolution. Don't forget that. Second thing, agitating a solution. Agitating means steering, shaking, or any movement that helps to dissolve faster. Agitating a solution can be steering or shaking, helps to disperse solid particles and increase, again, what are we doing by steering? Increase contact between solvent and solid. You are making more contact in a smaller time, in a lower time. This speeds up the dissolving process. Then this will help to dissolve more. Let me show you a figure, or let me draw you a figure. Like this. Like this. This is a container. We have some sugar put into this container. All right. This is some sugar. It's not dissolved yet. Not dissolved yet. If we leave it like this, some dissolved solute, look at the second point. Very close to the surface of a solute, the concentration of dissolved solute is high. Very close to the surface of a solute, the concentration of dissolved solute is high. What does this mean? It means that here, so this is also, again, let me draw some more sugar here, solid sugar. At this point,
بس شكرك هيك تاني
او شكرك يعني اي شيء تاني
اي شيء تاني
والله بالله كردمان انا اوكو we have water, sugar in water, but at this time some with, let's say, with green, some solute on this surface is dissolved here, but it is concentrated. Khasta Basha, concentrated. This concentrated dissolved solute will form a barrier. Here, let's draw it with blue again. This is pure solvent. This part is sugar. All right, the red is sugar. The green is the dissolved, some amount of dissolved sugar. But the problem with amount of sugar, the dissolved sugar here, it is actually blocking the pure solvent to be in contact with the solid sugar. It is making a barrier. It's blocking the way. Why? Because it has dissolved. It's so concentrated that it does not let these two mix easily. So what do? You start to steer, you start to agitate the solution so that you can bring fresh solvent. This is fresh, pure solvent, to bring fresh solvent to the solvent. And to the solute, sorry, the solute will be mixed inside this solution, and fresh solvent will be easily in contact with the solute. شكلك برزكيتو بسرعة لقل شيء يكلكي لقل solvent فريشة لقل أوكيك هشتا برينا كوتوا وایلی ئەکەیت لە ماوەیەکی کەمە کۆنتاکتێکی زۆر وایەکی لە ماوەیەکی کەمە خێراتر بکرێت. So when you are actually steering, you are speeding up the process. How? By making more contact between the solute and the fresh solvent. So steering helps to disperse the solute particles and bring fresh solvent into contact with the solute. That's the work of agitating the solution.
Sir,
Yes.
Can we say that when we stir the solution,
Yeah.
we also increase the area, surface area?
By some way you can, yes, you can. If there is no area in the sugar here, like in the red part, if there is no surface area, only one surface area is exposed, yes, at that time you are exposing more surface area to the solvent. Same thing is true. Because it's both of them are actually the same. What are we doing here? In both of the points, we are increasing contact, more contact between the solvent and the solute. Yes, it's kind of also true if you think about it like that. Yes. So until now, we have 2 points. Increase surface area. How? By breaking down the solute into smaller pieces. Second, agitating a solution. Agitating a solution is also increasing the dissolution process, the dissolution rate. That is 2 points. Third one, heating a solvent. So this is also directly proportional with dissolution rate. This is also directly. Third one, heating a solvent. Whenever we talk about heating or increasing temperature, normally I tell students in 11th grade, but for now, for you guys, maybe you haven't heard of this. That's why I'm going to tell you. From now on, in any chapter that we talk about temperature, we talk about heating. If we increase temperature, one thing increases, and that is energy. What type of energy? Kinetic energy. Always. Every time, if I ask you, we have increased temperature, what has happened? You will say kinetic energy is increased. Then we'll answer more questions after that. But you have to think about it, especially when we talk about particles, kinetic energy increases. All right. Kinetic energy is equal to what? 1/2 mv squared. What is V? V is speed or velocity. Let's talk about just speed. So if we increase temperature and kinetic energy increases, what else does increase? Speed. Speed of what? Speed of the particles. Particles of the solvent, particles of the solute. Then at that time, the collision, the contact between solute and solvent will be more frequent. They will contact more. They will have a better contact between them. All right, they will have a better contact between them. That is the effect of heating a solvent. So what happens? This helps to disperse, again, dispersing. All we do here is dispersing a solute throughout the solvent, among the solvent, and speed up the dissolving process. اما چیه کرد؟ واقعا زیادتر بلا ببێتەوە کە تۆ گەرمێکیت زیادتر بلا بێت. In the ministry exam, how do they ask questions? Like this. This is from last year, the first term. Which dissolves most rapidly? So the questions are like this. They will not ask you which one is fast only. They will tell you which one is fastest or which one is slowest. Here, which will dissolve most rapidly? Let's start with A. Sugar cubes and cold water. Sugar cubes, we don't have high surface area. Cold water is cold. We don't have high temperature. So this is not true. This is not fast. B. We have hot water, but it's still sugar cubes. We still don't have a high surface area. C. Powdered sugar in cold water. powdered sugar in cold water. We still have, yes, we have powdered sugar, but the water is cold. The water is cold. That's why it cannot be the fastest still. But the last one, it's powdered, the surface area is high, and the solvent has been heated, hot water. So this must be the fastest. What if? The question becomes, which one is slowest? كمان خاطرينا. Then at that time, the answer is
A.
A. Exactly. بس هي وزاري أوايته. يعني اشتدنا يا بلا ولا أي باش من شون بزانم سي وبي كمان خيراتنا نازاني. أو بإكسبيرمنت أو حق فيها مسرته. بس هي وزاري عادة على يان أمسري أو سري يان أمسري أمسر. يعني يان باشرين يان خيراتري. يان خيراتري يان خاطري. هيش تكمل. عشان. Do you have any questions? All right.
ما صح
بابا
عفوا بس ثاني خالص من باركته أزرنا به بقول
خالص سيام هل كانت قوتي heating a solvent يعني شيء يعني جرم ما كردو يعني temperature ما بس كردو هل كانت temperature بس كراو يخشى لما اشتغل أنا kinetic energy زيادة kinetic energy حاجة شيء بس رموه kinetic energy كمادة زياكري يعني خيرية ومادة زياكردو جواكي زياكردو إكتو شاكت جرمة كجرمبو بارتيكلين خيرات الجولان لقل تيجانا كشابون منه يا أجر تيجي شينيت مثلا زور جرها بو تشاكا وانا جرم بوا شكرك لبني برداخ كتابوا لقل تشاكا وانا بجرمي تكلا سيرجي بيجو تو تيجي بيو تواتو بو لبري بارتيكلين سولفنتك وانا جرمه وانا خيرا كونتاكتي كدو لقل سولفنتك يا فرياكو تو همي بتوينتو كواتا تشي هو كاركا خيرايي بارتيكلكانك أجولانا عشان بابا
يعني ما مساتاكو يعني أوكا يعني شاكا جرنتر بين ساتر بي يعني بارتيكلا كان فرق كاتا ساتر بي كم تر الرياكشن يعني هلا بيني
عشوان هتاكو جرم ببارتيكلكاني زور خيرات الراس ما بتشاي خومن بس هل ما كبيني أشتك بيني بالام زور خيرات بارتيكلكاني أجولانا باشا مثلا بولي خوش بين مثلا بولي ينزل مثلا بشي كتير على شابتر شاشة بس evaporation نكات أو بوشي evaporation نكات بوشي أكله ببجاز أولا هو شابتر شوار تنخونه لبولي ينزل يا شابتر شوار على شيء so in last year in 11th grade in chapter 4 it says that gas particles have a very high kinetic energy. That was one of the assumptions. It has a very high kinetic energy. So when also a liquid, for example, water, when it takes a lot of kinetic energy and the particles move fast enough, they lose the attraction between the particles because water, as a liquid form, they have attraction forces. That's why they are liquid. That's why they stick together. But if we increase a lot of temperature, if we increase the kinetic energy, the attraction force will be lost. There will not be any attraction force. So the particles move so fast that the bonds between them break and they become gases. جابن بغاز وكان وانا خيرا جولتوا particle كان بغاز اما باسي kinetic energy وبابلن حقي بسر action force اكبر او مثلا للشابتري تشوارا in chapter 4 last year one of the points was gases don't have attraction forces. Why? Because the kinetic energies are very high. But water have attraction. Water particles have attraction force. But if they have a lot of kinetic energy, they will lose that attraction force and they will become gas. Same thing is happening here. If you increase the temperature, kinetic energy is increasing, the particles are moving a lot faster. That's why they dissolve more. That's the point. So that was only rate of dissolution. How fast something can dissolve. أنا بس خيرايبو لا تنتج نتشة. شكل دواترة باسي amount شكل. Now let's come to solubility. What is solubility? Let's understand it. If you add spoonful after spoonful of sugar to tea, eventually no more sugar will dissolve. Of course, It will, whatever you do, even if you steer it, even if you make it into, like break it down to smaller pieces, it will still not dissolve. This illustrates the fact that for every combination of solvent with a solid at a given temperature, there is a limit. What does this mean? It means that every solid inside a solvent at a certain temperature, there is a limit. For example, at that temperature, only this amount of solid can be dissolved in a solvent, which we'll get to later by numbers. We'll talk about the numbers, how these limits are reached. But the limit depends on three things. That limit, the amount of solubility. When we are talking about solubility, we mean maximum amount of solute that can be dissolved. Capacity solubility maximum amount of solute can be dissolved. That's what solubility means. That's the limit. أو limit كان solute تتواني لنا أو solvent. So it depends on three things. Or you can write solubility depends on, like this. Depends on. Then they got succession. A. In the book says three things. A, nature of solute. What is the solute? For example, sugar, glucose will dissolve at a certain rate, at a different rate than, for example, NaCl, than another solute. For example, NaCl will dissolve at a different rate than calcium chloride. They are all different. So that is the nature of solute. Second one, nature of solvent. Sugar will dissolve in water at a different amount than sugar inside alcohol, inside ethanol. تو الشكل الأول بتويني تو جاوز وقلي الشكل لنا ethanol بتويني كاتو nature of solvent. That's nature of solvent. Third, temperature. If you dissolve sugar in a cold water, it's different than dissolving sugar in hot water or other substances as well. NaCl in hot water or cold water. We'll talk about those all later on. Which one will dissolve more, which one will dissolve less, and how can the temperature will affect the solubility. So that's the third one. Please add the fourth one, which the book hasn't clarified it entirely in the book, which is pressure. But pressure is only for gases and liquids. When we talk about pressure, the effect of pressure only for gases and liquid, only. But these three are for all. For all. بو همو ماده كان او سيانه من هي بس بو غاز بعملين بس بريشر بس بو غازه يعني بغازي او سيانه بو غازي شبه بس كباسي بريشر كم بس تنها بو غازه بو نال سوليد وشتوانا. All right, so we have all those 4 points. Let's continue. When a solute is first added to a solvent, solute molecules leave the solid surface and move about at random in the solvent. So when first we put in some solute into the solvent, the solute molecules will leave the solid. And why? Because it's starting to dissolve. Here means start to dissolve. As more solute is added, more collision occur between dissolved solid particles. So if we have a container that there are a lot of solute dissolved inside that solution, then there's a contact, there's a collision between those two, between the particles, all of them. That's why sometimes some solid particles return to the crystal. جاروا چی لید؟ collision كان هنا زورة بيت الرنجة ببنوا crystal. What is happening here? Why is it becoming a crystal? Or how it's becoming a crystal? when maximum solubility is reached, when maximum solubility is reached, it means that when no more solute can be dissolved, that's the maximum. When it reaches solubility, no more solute can be dissolved. Molecules are returning to the solid form at the same rate at which they are going into the solution. What does this mean? I have to draw you a figure here as well. Let's say we have started to put some solute, some sugar into some water. Now we have the water here. This is the water and some sugar, but we stir it, and we agitate it or break it into smaller pieces. We still have some parts, some precipitate left here. Why? Because the solution has reached its maximum amount or its maximum ability, which is called maximum solubility. It cannot dissolve any more sugar. That's it. We are done. It's locked. At that point, what is happening? The system will reach a state called equilibrium state. Let me explain what is equilibrium. Not related to this one, because you guys studied equilibrium in 11th grade, but we will study, don't worry about it. I will explain equilibrium here, and we will have another subject about equilibrium in chapter 7. So don't worry about that. Don't say that we haven't studied that last year. I will try to make it as clear as possible. But you have to understand equilibrium. What is equilibrium? Some students think that when we talk about equilibrium, it means that two amounts of something are equal. But when I want to explain equilibrium, what is equilibrium? Not two amounts are equal. Two changes are equal. Let me give you an example. You are sitting in your room right now, let's say. That room only can take 15 people, 15. At first, the room is empty. In the outside of the room, there are 25 people waiting. But inside the room, we can only take 15. So when we open the door, there is only one change, which is coming inside the room. People start to come into the room until it reaches 15 people. 15 people. When it reaches 15 people, we'll say it's done. We cannot take anyone else inside. But the system is like this. Those 15 people shouldn't stay for all times inside that room. There should be a change. There must be a change between those people. So what happens? If we will tell the people outside, we will take one in if one of them goes out. We will take one in. For example, if one people, let's say they have a work inside that room. When their work is done, they will go out. Or it must be a system that when some people must go out, some people must come in. If one person goes out and one person comes in, or two person goes out, or two person comes in, now we have two changes that are equal. What are the changes equal? Coming in and going out. Coming in and going out are equal. The amount inside the room and outside the room are not equal. The amount, it can be equal, but it doesn't have to be equal. What must be equal? The changes when two people goes out, when two people comes in must be equal. That's what it's called. At that point, we will say that our system is at equilibrium. Our room cannot take more than 15 people. But the 10 people waiting outside can enter in for the next hour. If you want to see the people inside your room, they are not the same people which were inside the room 1 hour ago. اگر تو مثلا دوای ساعت سری او خلقانه بکن که لجورکتا که 15 کس که لجورکا سری که همان 15 کس نبود که لجورکتا بود چی کردوا به بردامیش جگوکان کرد خو هر به بردامی 15 کسی تیه بەڵام هەمان 15 کەس نین. All right? So it's not the same people inside your room. The people are, or the persons are changed, but it's still 15 people. Same thing is happening here. And let's come back to chemistry now. Let's come back to solution. When we are dissolving some solute, at first, the solvent is still dissolving until there is a point where the solution is like the room. It says I cannot take any more solute. What happens? Some solute particles are precipitating, but these solid particles will not stay as solid throughout the solution. What happens? They will say we also demand to be dissolved. Then some solid particles, the solid ones, will try to enter the solution, dissolve. But since the solution has no more place, no more room for solution for solute, it has to kick out some more solute. We call this process as crystallize, which is becoming solid again, becoming from solution to become solid again. We call it crystallization. All right. At that point, if 10 molecules dissolve, at the same time, 10 molecules must crystallize again. That's what we call it. This change, the change is equal. The dissolved and the precipitate are not equal. The change, which is dissolution and crystallization, are equal. Maybe if there are 50 grams dissolved, only 10 grams is not dissolved. But the change between them are equal. We call this state what? Solution equilibrium. بم حالة على شيء solution equilibrium يعني solution equilibrium. ماشي. And is the physical state in which شرحك opposing processes, two processes which are opposite of each other. What are the opposing processes? Dissolution and crystallization. So always, if in ministry exam says what is solution equilibrium, you will say it is the rate of dissolution or dissolution rate is equal to crystallization rate. كواتا قال برسياري وزارية لأن اجتماعية وتي solution equilibrium تشيا لبيني شيا طولي لبيني dissolution ولبيني crystallization الرجي dissolution rate dissolution يكسان بالريت crystallization. All right. Always in solution equilibrium, when it reaches its maximum solubility, the rate of dissolution is equal to the rate of crystallization. That's what it's called, the solution equilibrium. Yeah.
جانا خوش به يعني او رجعي كتواوتو لقل او رجعي ما وتو لناو لجلوا كسولف نبو بيلن solution equilibrium و
equilibrium. سيريكا اللي ما تقنتش او كتواوتو لقل برستيتيكا يكسانين بلا گۆڕانکاری لە بینیانە کە بە بەردامی بەدلەکەن بڕێکە چی ئەتوێتەوە بڕێکێت ئەوە سۆڵیت ئەمە هی ئەوترێ solution equilibrium. ئەمە چیە dissolution و crystallization یەکسانە بێت. شکر خۆم مامۆستا
کاتێکە crystallize دەکە هینە ئەو کاتە ناوێت بە suspension
خۆی ئەگەر بەعام هەمووی سیر بکرێت تا حدك بس suspension حسابك بلا اما اللي رأي أصلا ناوي بقى في ناولين suspension ناوي كتير بوانين كالأخوار وأي خاني باشا لبري بيبلين suspension ألين solution دروس بوا بلا مثلا كاللقى بما هو فلانا solution كالأخوار وأي خاني يقصد كابرتي أجاد كاللي رأي أجادي هي precipitated كبو يعني يجشتي بلا ملبلوي yes.
Not all of the solutions solutes crystallize. For example, non-electrolytes.
No. Non-electrolytes also can crystallize. Why? For example, sugar. We are talking about solid solute, which can dissolve in a certain amount of liquid, in a certain liquid. For example, for water, sugar, which they are non-electrolyte. But are they solid? Yes, they are solid. As long as they are solid, yes, they will crystallize. We don't care if it's electrolyte or non-electrolyte. As long as it's solid, all right? And it dissolves in water.
Okay, thanks.
Asha, you're welcome. So this is solution equilibrium. بسیارەکەی تشکی هێشتا مەسەن ئەڵێ مامۆستا سسپنشن چونکە ئەمە بەشەکەی تریمان هەمووی تواوەتەوە مادام توانەمان هەیە کاتە قسەی سۆلوشنی بۆ بەڵام لە سسپنشنە شتێکمان نەبوو بە ناوی توانەوە مەسەن بەناو هەموو شتەکانە هێترۆجنس بوو ئەوە کێشەکەمان هەبوو بەس لێرە بەشەکانی تری هەمووی هۆمۆجنسە بەس تەنها بەشێک لە ژێرەوەیە وای لێ کردووە کە ئەم حاڵەتە دروست بێت جاک لێرە هێنیش دروستە بێت لێرە ئەم حاڵەتی دیزۆلوشن و کریستاڵایزیشن دروستە بێت لە سسپنشنە ئەوەشمان نییە باش بخۆم. Now, if you don't have any questions, we have done with the first lesson. We will try to continue in the second lesson after 10 minutes. You can take a break. I will not close the video. If you want to close it, you can do it, and you can come back again after 10 minutes, but we will leave it like this, all right? All right. I hope everyone is here. Before we start our lesson, let me talk about something that most of you have been wondering about, and that's quizzes. We'll try to start our quizzes maybe this week or next week, maybe. But we are still thinking about how can we give you the quizzes, or which way is the best way to use the quizzes. But the way we do it, for example, for chemistry, I don't know for the other teachers, but for chemistry, I will try to make it for every chapter. Since we are giving the quizzes for you, or you can solve it at homes, so you don't have to make every quizzes in every section. I will try to make quizzes for every chapter that we studied. Maybe each chapter I will ask like 20 questions or 25 questions, and you will study. We'll tell you which day. We'll try to, each teacher will try to give you a day. Don't worry about it. We'll not give you 2 quizzes in one day. For example, we'll collaborate with the other teachers. We'll talk about which day is better for me, which day is, for example, better for Mama Sadana or Mama Barham or Mama Najdat. Each one of us will have a certain day, so that we can we don't get mixed together. We don't have different things like this, or like in one day you have 2 or 3 quizzes. Each day you will have only 1 quiz, and I will try to give you like for a certain amount of time. For example, I will say that the quiz will be open from 8 p.m. to 9 p.m. and you will have like 30 minutes. So it will be open for 1 hour, but you will have 30 minutes. But there is something else that I have to tell you. From now on, you know that you are a 12th grade student. And in this course, if I give you a quiz, the quiz is for you. It's for your evaluation. Yes, we will give you grades. Yes, we will tell you which one is wrong, which one is not, which one is correct. But be very careful. You are responsible for your own grades. You are responsible for your own quizzes. When the teacher gives you a quiz, please don't try to solve it together. Please try to solve it alone. Or if you have studied in your notes, try to not open your book. You can open your book, it's better, but it's better than to solve the questions with your friend, because you are evaluating yourself. And this is a course. Your grades are not important. Your grades are not something. I will not look at you as say, why did you get this grade? I will look at it. I will tell you, why did you make this mistake, so that I can help you, so that you can help yourself, so that you can know what you have studied or not studied. In the previous years, every year, like it's been like 4 years that I've given courses during the summertime. In most of the quizzes, when I give the students the quizzes, I'm either out of the class or in the class, not looking at any student. I will tell them they can cheat. They can look at each other. I don't care. You are the top grade. You will not benefit. You will be the one that make the mistakes, not me. The grades are not for me. That's why. Be honest with yourself. Most of the times in class, I'm busy with my cell phone. Even if you are in class, I'm busy with my cell phone. I don't look at the students. I don't care what they are doing. I have given them the quizzes. I'll check it for them. I'll give them grade, and that's it. The rest is up to you. Even during school for 12th grades, since they are not 11th grade, yes, 11th grade, their grades are included for their report or for the ministry or anything like this. But for 12th grade, everything that they do is for themselves. That's why even during the school time, I don't care if they cheat or they look at each other, or sometimes I give, even at school, I give the quizzes to take home, and I tell them, you can solve it with your friend, you can solve it with open book, that's up to you. But it's better to solve it by yourself and with a closed book. All right. So do the same thing here as well. When we give you a quiz, try to solve it by yourself. If it's better if you study first, then answer the quiz. All right, so that you evaluate yourself, you assess yourself, and see what do you know and what you don't know, so that you can go back and study again. All right. Now that was the quiz subject. Let's continue with our subject. We talked about solution equilibrium. بەڵێ
عفوا داوای لێ بڕناکەم
هاتە دیگەن
من یەک تۆز درەنگ شتەکان وەرەگرم یعنی تۆزێک پرسیار زۆرەکەم ئەگە خاترم مەگری
زۆر ئەتیادێ کوڕم زۆر ئەتیادێ ئەمە جا کۆرسمان بۆچی کردێتەوە بە لایڤ بۆچی بە لایڤە بۆی پرسیارکەین
مامۆستا بورە ئەم دوو خاڵی سەرەوە یەک جاری تر بۆ شەرحکەیت مەمنونە بووم
باسەر
چاو خۆش بێ زۆر سپاس
سیرەکەین ئەم دوو خاڵەی کە با بڵێن ئەم دوانە ئاڵێوانە
بەڵێ بەڵێ مامۆستا ئەم دوانە
باشە I'll let you, when a solid is first added to a solvent, solid molecules leave the solid surface and move about at random in the solvent. كم جاتو solid يجاكيت ناو solvent كوا بومنا كريك NaCl يجاكيت ناو أو يا كم جاورد تشي رويات برجل solid كا برجل salt كا يا شكل كا هر كامي كم بد برضو ده لsolid درجة ما عندي بس solid نامنه solid كا بتجي هلا تو تشتناو أوكو تشتناو لكيديا كو بومنا أبى بتواو أتوتو as more solid is added, more collision. فتاكو زياتر ببد شي رواية solid كان لنا خو أبون من يتشكل كه اتونيو لنا وش هنا تواوكيا خو particle كان ونبون راسي من نبيني راسي كنتو تبيني أو كانوا بس خو ما هو دبيع بس molecule جابت لنا molecule كان شان ليه وردو ده كزوربن نزيك ابنوليك وكوا بابن جوريك ما هبه جوريك قال كم جار بيانش كسيتي دان شريك ولا سوجا كدانش تجيبه بتو بس ورا أو جورة شركة سيتيكا وردو ده شيليت قربان قبل وبركوتي أو شركة زياكا أمي جوا كلك وردو ده زيادة تويتوا بركوتي بين الشكل كان ما بين السوليد بارتيكل كان زياكا ليرا تواي ليت أجر زور بتشي كان بريك كونو هنجا يك جرنوا شو كبيشتر شيء على هاتو جابونا تو بوبا واوا بلام دوای ما أجر زور قربان بيتو يك جرنوا دلسكاتو بنيشتن لم حالتها كنيشتوا ألين شيء ألين تواو أو يترس أو ليكويدكا ياخد أو solventكا تحملي نما لو زياتر ناتوانا بتوانتو لو كاتا solid كان بونتو بس solid شي رياوة equilibrium رياوة equilibrium شيا على molecules are returning to solid from solid form at the same rate at which they are going to the solution يعني أكاتا حالتك شان يك molecule أبي بس solid لبرامبرش أونا هي solution كو يعني كان يبقى solution لبرامبر ونص أبيته بس solid بوي precipitate دروس بقى أو حالة الشيء بيالين solution equilibrium بيالين تشيبو يعني أقصد أو ديرك الأخير جاروتي بيش equilibrium state كذا بيش دار فوركوا أو يك تيتو هش تمجمع أي شيء ما وش تان بتوتوا في روايات أما هو بتوتوا والله أي جلط هاد جيجان ما يكسر شيء قال لهمان كاتا نختي كي تر precipitate بيكاتوا على بروزي جينيا برو بس solid ببردوامه بشتوكو السايكليك بردوامه به always دايناميكا يعني دائما لجوله ناوست باش بابا
ما يعني بارتيكل كان عين اماونت يعني هي بس اوي كاتيكا خريجات وينما يعني الرياكشن كان ينزعك على بيني اخوانا
بركوت كوليجن زياكا بركوت نكان ينزعك بركوت زياكر اتوانه جاري كتير ببيتو بس سوليد اتوانه جاري ببيتو ببريسبيتيتك
تيجيشتم دست خالص بس
Now, we classify solutions depending on the amount of solute, depending on this thing. How much solid do we have in the solution? First, we call it a saturated solution. What is a saturated solution? A solution that contains the maximum amount of dissolved solute is described as saturated solution. So if it contains the maximum, what does maximum mean? It means that it cannot dissolve any more solute. It cannot dissolve anymore. It has reached its maximum limit. That was the limit we talked about. The maximum limit. What do we call this solution? Saturated. But Kurdichi Piotre Girawe Ter. It's saturated, it's full. It cannot take any more solute. It cannot take anymore. How do we recognize a saturated solution? How do we know a solution has reached saturation? What does it say? if more solute is added to a saturated solution, it will directly fall to the bottom and does not dissolve without any change. كواتا قربيتو بالرجل solute man كده na solution يكو يكسر نيشت. And if you add some solute into a solution and it directly precipitates and it falls to the bottom of the container, you can think, oh, in that case, this solution has reached its limit, then the solution is saturated. The thing is here is direct precipitation and falling into the bottom. That's how we recognize a saturated solution. Why? This is because a saturated solution, when it reaches maximum on the above part, when we said it reaches a maximum, what happens? It reaches what? It reaches equilibrium state. It reaches equilibrium state. So this is because equilibrium has been established between ions leaving and entering the solid phase. So between the ions or the dissolved molecules, even if it's dissolved, then when a solution is saturated, from now on, when a solution is saturated, then we can say this solution is at equilibrium. Why? Because it has reached its maximum amount. If there is amount of solute, it will precipitate in the bottom. And you know that if we have a precipitate on the bottom of the container, the rate of the solution will be equal to the rate of crystallization. So اگر وتی بابلن گشتوت به ساتوريتد سولوشن لچه حالتی که الان ساتوريتد سولوشن لحالت اکولیبریوم بو ساتوريتد يعني گشتو به ماکسیمم همش لسر و باس ماکروت من که گش به ماکسیمم يعني حاضر پرسپیتی درست که او کات پرسپیتی کش خوب اینی نامینه تو به هر واه نامینه تو چیه کات به بردامی لسایکل که برک حالا بتوی تو برک حالا پرسپیتی که. That's why saturated solution, since it's maximum, some amount of solute is trying to dissolve, and some others are trying to or some molecules are precipitating at the same rate. That's why it is equilibrium. And whenever it says solution equilibrium, we have to think about of these two things: dissolution and crystallization. Dissolution and crystallization. All right. What if the amount of solute still hasn't reached its maximum amount that can be dissolved? What if it's still less than the maximum? What if we can still dissolve more solute? We call it unsaturated solution. Nater, bakudi girawi nater. Unsaturated solution. So a solution that contains less solute than a saturated solution under the same conditions is an unsaturated solution. What does it mean, same condition? For example, the same temperature, the same amount of solvent. If you put less than that, it is called unsaturated. Look at here. This figure. Look at this figure. In the figure, this is solubility of NaCH3CO, sodium acetate. Sodium acetate. The amount of solvent is constant, which is 100 grams of water. And at which temperature? 20 Celsius. The temperature is very important. Will not change the temperature. And will not change the amount of solvent as well. Then, at that point, what is the maximum amount that can be dissolved? It says the maximum amount that can be dissolved is 46.4. That can be dissolved in what? In 100 grams of H2O. So we can dissolve 46.4 grams of sodium acetate in 100 grams of H2O. Let's see. The saturated is 46.4. So at that point, it has reached saturation. It's saturated. Even if you put more, what does it say? Even if you put more, some solute remains undissolved. It's still saturated. يعني اگر بيتو نختي كي زيادة شيء يمكن هاد saturated ده. بلام شيء لقلاه precipitate لقلاه. But less than that. So below this point, below here, anything less than 46.4, for example, even 46, 40, 45, 25, 30, all these parts are called unsaturated. All these parts are called unsaturated. كواتا هر رقمك كان أنا دقت شلو شش بيت ما دام هشت أنا قشتو بماكسيمم مجالي هي مجالي هي كي تربتو أنا تو أو بي أو 3 unsaturated. بوي اللي راك أنا بلند شيء بو unsaturated. أجل بو كنا تجناسينو we can say more solute can still be dissolved in the solution. وقتها أتوانين هشتا نختي السوليوت يتريش بتوانينا ولا ناو solution نكا. أما unsaturated solution. تاكت تاسب باسي دوان ما كدوا. Saturated, which is the maximum limit, it cannot dissolve anymore. Anything that we add will precipitate in the bottom. But unsaturated is a solution which still can take more solute, which still can dissolve some more. It's called unsaturated solution. Anything less than saturated.
ما وصل برسالي حسابي من بويته ولا سلامة؟
هنا ما تحسبيش بودانا ونخواره. بلامتا اساك نهاتو طول الراستيا بزن من دامنا وبوية قربيتو شوازي كي تقوري تبقان. بلاما ما بلو كاتها خوي معلومات من بعد. باشا؟
Sir?
Yeah.
May I ask a question?
Yeah, please. Go ahead.
Let's think of a solution. When we put more of the solute to the solvent, it precipitates
Exactly.
forms.
Yeah.
But when we heat it, more of the solute can be.
Let me stop you there because we are still not there. All right. Wait for it because the next subject is like that.
Okay.
All right. The next subject is that one. All right. So the next thing is supersaturated. Supersaturated solution. What does it mean? A solution that contains more dissolved solute than a saturated solution contains under the same condition. Under the same condition. Then how can we do this? We said when it reaches maximum amount, it's saturated. How can we dissolve more than the maximum? We have to trick it. We have to do something so that we can dissolve more than it can do it at that temperature or at that condition. Let's continue with supersaturated. What is supersaturated? What is supersaturated? When a saturated solution is cooled, at this point, you have to think about this. When it says it's cooled, it means that it has been heated first. So first, it is heated. Kawata, if it is heated, so more solute can be dissolved when it's heated. Again, at that point, when we cool it down from the heated, we have dissolved more, and during the dissolvement, it has reached saturated. So if it's heated and it's saturated, it means that it contains a lot of solute. It means it contains a lot of solute. And when it's cooled, the excess solute usually comes out of a solution, leaving the solution saturated at lower temperature. If it's heated, we have dissolved more solute. Then when we cool it down, the extra solute at that temperature, at the lower temperature, will split out of the solution. But sometimes that excess solute will not separate. If it doesn't separate, what is formed? A supersaturated solution is produced. A supersaturated solution is produced. Now, Before we get to the last note, let me explain supersaturated solution on this figure. Let's look at this thing, or this information. This information, will understand everything from this information. It says, if you have a solute can be dissolved in 25 Celsius, the maximum amount that can be dissolved is 91 grams. So this is maximum. But the same solute at 50 Celsius can be dissolved, 150 grams can be dissolved. So this is also max. So this is maximum for higher temperature, this is maximum for lower temperature. All right. Now we have these two information. Let's, according to that information, let's look at the figure. First, we'll put some solid into the solution. Before we stir it or we agitate it, 5 grams is dissolved by itself. It's still dissolving. What does it say? Still dissolving. But after we stir it and for example, we increase the surface area, what happens? 91 grams of the solute. Why? Because we said at 25 Celsius, only 91 grams can be dissolved. But how much we have added? You can add this, you can write this one. 100 grams of solute is added. From that 100 grams of solute, only 91 grams is dissolved. So 91 grams is dissolved. We have added 100. We can see at 25 Celsius, only 91 can dissolve. What about the rest of it? The 9 gram is extra and it will precipitate. It will precipitate. Now, what happens if we heat it? This symbol means heat, means heating. What happens if we heat it? Heat it to which degree? To 50 degrees, to 50 Celsius degrees. At 50 Celsius, how much solute can be dissolved? 105. But how much do we have here? Only 100 now. From 91 with the 9 grams together will become 100 grams. So it's still at 50 Celsius, it's still what? It's still unsaturated. It's still unsaturated, but it's 50 grams. It's 50 Celsius. When we cool it slowly, the 100 grams, what do we say in the second point? Sometimes the excess solute does not separate. What will be produced? A supersaturated solution is produced. So when we cool it down slowly, to which degree? To 25 Celsius. But at 25 Celsius, how much solute can be dissolved? Only 91 grams. But we have tricked the solution. First, we have dissolved 100 grams by tricking it, by heating it. Now, when we cool it down, the excess solute will not come out. The excess solute will not come out. Then a solution will be formed, which is called supersaturated solution. Why? Because at 25 Celsius, only 91 can be dissolved, but here 100 grams is dissolved, no precipitation. Supersaturated can never have precipitation. Had precipitation, it is supersaturated. Then we call it supersaturated. Why? Because more than it can dissolve. It can at 25 Celsius it can only dissolve 91 grams, not 100 grams. That's why it's supersaturated. Then let's get to the last note here. Dropping a small amount of crystal of the solute into the same solid, if we drop the smallest amount, only a little amount, which we call it seeding. Or disturbed. How do we disturb it? By shaking, for example. We disturb it. then the whole supersaturated solution will disturb. It will get mixed. So what happens? We have a lot of solutes. We have to do something. What will happen? All the extra solute will come out of the solution and becomes saturated again. And the extra solute, how much extra does it have? Did it have? It had 9 grams of extra solute. That's why it becomes saturated. Chile had هرچی زیاد بو هر هموی هات درو هموی هات درو بچی از زنیمان که سوپر ساتوریت اگر وتی هرچی زیاد کش هوا هات درو لغیری خوی بو نمونه تو چی 0.1 گرم لسولیتیه که چند هات درو 9 گرمی تیش لگل هاتو درو کاتم سولوشن چی بو کاتم سولوشن سوپر ساتوریتد بو سوپر ساتوریتد بو باشه. Let me give you another figure. For example, after this, we have, I will put some more solute at 50 Celsius, right here, 50 Celsius. We have 105 grams dissolved. So what is this solution? It's saturated. Why? At 50 Celsius, we can dissolve 105. That's why it is saturated. What happens if we if we cool down this one? And we don't disturb it. We cool it down, we don't disturb it. Cool down to which Celsius? To 25 Celsius. To 25 Celsius. At that point, all the 105 grams is still dissolved. Still dissolved. If it's still dissolved, then at that time we will call the solution as supersaturated. Then, if we disturb it, how many grams? It will become what? It will become saturated, and only 91 grams is dissolved. How many grams precipitate do we have? 14 grams will precipitate. 14 grams. Why? Because we come from 105. If you want, you can draw this figure as well next to this figure, or you can draw it anywhere else, maybe in your notebook or on a sticky note. You can write this down as well, so that you can understand what other possibilities do we have here. But at this time, only the amount has changed. If we have more solute, of course, more precipitate will be formed. The disturbing is by shaking or just seeding. Seeding means adding some solute, in the smallest amount of solute into a supersaturated solution. Supersaturated. All right. I will leave it for a couple of minutes. I will leave it like this until you write down these figures if you want. And in the meantime, do you have any questions? Who has any questions?
مامۆستا لەژێر ئەوەی سوپەر ساتوریتدەکە ئەوەی گرافەکە نووسیوتە نۆ PPT ئەومە بەسە نۆ پرەسیپتیشنە
بەڵێ کامیان
ئەوەی فیگەرەکە ئەوەی کە خۆی
ساتوریتدەکە ئەخی دانیان
بەڵێ نە سوپەر ساتوریتدەکە
سوپەرساتوریتدەکە لە کامیانە بەڵێ نۆ PPT ئاین پرەسیپتیشنی نییە
دەخۆش
زۆر باشە. بابێن let's solve some questions on this subject. Which of the following is wrong for a saturated solution? Saturated solution is at equilibrium. Yes, it's not wrong. So it says which one is wrong. Rate of dissolution and rate of crystallization are equal. Yes, correct. Adding more solute will fall to the bottom of a solution and does not dissolve. Yes, that's also a property of saturated solution. But adding more solute will dissolve and disappear. No, this is not correct. This is a property for unsaturated solution. That's why the answer is D. Next question. If a student adds solute continuously, that disappears in a solution, that solution is called what? حتى يكاد ونبت. يعني شيء ونبت. يعني dissolves.
Unsaturated.
Unsaturated, yes. So the answer is actually C. The answer is C. But a student stopped adding solute into the solvent after forming first crystallization. So when the student saw, it's like after stirring, when he saw the crystallization, when he saw the first solid or the first precipitation, it means that the solution cannot dissolve anymore. Then the solution must be what? Must be
saturated.
Exactly, saturated. باشا كواتا مادام لقل بيني وستاو بريسبيتي كردو يتطاولو زاتناتو كواتا solution جيشتو با saturated. But if when a saturated solution, so it means it contains high amount of solute. At high temperature, it contains a high amount of solute. It's saturated. So if it's saturated at high temperature, if we leave it to cool, and the excess solute does not separate, so it's still dissolved. It's still dissolved. And if it's dissolved, still dissolved at lower temperature, and when saturated, cool, left to cool at lower temperature, then that solution is super. So the solution is supersaturated. كاس بسياري يا بابا جنب.
صح.
بله.
أزل نبي تواني كدرسك طاب يكتوز مين تو حرسي كم بدي بشرح كده أزل نبي.
كام بابا جن؟
أتواني يعني كدرسك ما طابو إسابرو يعني بس كدرسك طابو حرسي كي سوبر ساتوريتد و أن ساتوريتد و ساتوريتد بكل بشرح كده
جا سبوش. أشيك استبوش شرح كمان من في إذنك بس مثل الموضوع كتبوها. سيركا أجاب كل بشرح كمان.
هلا.
أو سجل solution ما هي. أجر هاتو solution بطواوتي جشتو بوا. maximum يعني لو زياتر ناتوانه بتوينتو هم او اويك همان او رجع اويك ديال كراو ياخذ من او بيان هر ما ديك تلبن او رجع كديالي ما كردوا لحد يقايت لو زياتر نيتواني بتوينتو بون 100 جرام او داناوا بركي شكرتيكي بركي سولوتيكي سيركت لو زياتر ناتوانه بتوينتو لحد يقايت برستيتك الان شي ام سولوشنا الان سولوشنا ساتوريتي دا يتتيرا لما حد يخوي زياتر ناتوانه بتوينتو هرشتك شي تيب كيد لو سوليتا يكسب انيشيت الجرا يكسب بريسبيتيتك اما ساتوريتد ده بلان اگر بيتو هشتا نگشت به تحدي ماكسيمم خوي بون مالن فلانه مادتي يكن اسا مثلا ويا علن شي 90 جرام توتو تو بشي 8 جرام تيبكي اي هشتا جيجي 11 جرام تر ما تو بيتو كواتا ام سولوشنا هشتا لك تو تحدي ماكسيمم خوي كواتا ان ساتوريتد كاتو unsaturated
يعني هيش تاتوان ديسولف كاد
هيش تاتوان ديسولف كاد او هيش unsaturated
اوكي
والله ما قربياتو اما فيلك لا سولوشن كبكين شلون قرميكن كقرم ما كده توين ازياتي تابتونينو مثلا لەسەر چی بوو خوینەوە یەکە توایەوە گەرم بوو بە 100 گراممان توانی بتوێنینەوە حتا ئەتوانی تا 105 بڕۆین جا عادەتەن ئەگەر وتی لە تێمپرچەرێکی بەرزە ساتورێتدا یعنی لەو تێمپرچەرە ئێستا تەواو ڕێژەیەکی زۆری تیاتوانێتەوە کە ساردی ئەکەینەوە لە تێمپرچەرەکەی خوارەوە ناتوانێت هەمان ڕێژەی ئەو بتوێنێتەوە چکە ئەو ساتورێتدا یعنی زۆری تیاتواتەوە بەس کە ساردی ئەکەینەوە واتە ئەگەێنی لە حاڵەتێک کە ناتوانێت ڕێژێکی زۆر بتوێنێتەوە بەڵام ئەگەر بە هێواشی ساردیکەینەوە زیاکەش نهاتە دەرەوە ئەگەر زیاکە نهاتە دەرەوە ئەو سۆلوشنە کە بۆ بڵێن فێڵمان لێ کردووە ئەوە زیاب بتوێتەوە بە سۆلوشنەوەتی لە چی سوپەر ساتورێت تاکەی وە ئەمێنێتەوە تاکەی بە سوپەر ساتورێتی دەمێنێتەوە هەتا کۆکاتی دیستۆربێکن نمونەی سوپەر ساتورێت چیە بۆن بەسەن لە وڵاتی خۆمانە چییە سوپەر ساتورێت یان لە هەر شوێنێک ئێمە کە شەکرە توێنینەوە بۆ نمونە دایک بەسەن لە ماڵەوە ئەچن شەکری هین حازرەکەن شیلەی بازانیان لۆقمەخاسی کە شیرینیخانەکان حازرەکەن شیلە حازرەکەن بۆ شەکرە حازرەکەن بۆ شیرینیەکان بۆ باقلاوای بۆ هەرچیەکە چیەکەن ئاوەکە کەمجا چیلەکەن ئەچن ئاوەکە قوڵێنن بۆی شەکری زۆرتر بتوێتەوە ئەی دوایی وردە چیلەکەن وردە ساردیەکەنەوە چی دروستە بێت شیلێ دروستە بێت سۆڵشتێکی سوپەر ساتورێتی دروستە باشە ئەو ئاوە ئەگەر خۆی بە پێشەوەی گەرمام کردا بە گەرمکردن نەبووە هەر بە ساردی بمان تا شیلە دروستەکە شیلە دروستە بوو نەوەڵا شیلە دروست نا ئەیە بە چی لێ بکەیت ئەبە بچی ئاوەکە گەرمیکەی بۆی چی لێ بکەیت بۆی شەکرێکی زۆری تا بکێتەوە ئەو بۆی شیلە عادەتەن بڕۆ مەسەن تامی شیلە بکە لە تێمپرچەرێکی دیارکراوە بۆ منە لە ژوورێکە دابێنە شیلێک لەگەڵ خۆت بڕۆ شەکراوێکی ساتورێت حازرکە کە بیتوێنەرەوە تامی هەردووگیان کەسەیەکی شیلەکە زۆر شیرینترە بۆ چونکە ئەو شیلێ هاتوون گەرمیان کردووە ڕێژەیەکی زۆر زیاتر لە حەدی خۆی شەکریان دەتوانێتەوە ئەنجا ساردیان کردوێتەوە گەشتۆ بۆ حاڵەتی سوپەر ساتورێتە لەبەرەوە ڕێژەیەکی زۆر لە شەکری تایە ئەوە پێوتێکی سوپەر ساتورێت باشە بابا ئەمە
ینی ئەم ئاوا زۆر ینی فۆرسێکی خراوەتە سەر بۆی زیاتر دیسۆڵفکار لە ناوخۆی
ئەتوانی وا بڵێن ئەتوانین بڵێن بەهۆی گەرمیەکە وەمان لێ کردو زیاتر بتوێنێتەوە گینان خۆی لە تێمپرچەرێکی نزمترا ناتوانێت ئەوە بکرێت ئێمە گەرمیەکەین دوایی هێنینەوە سەر تێمپرچەر نزمەکە ئەو کاتە چیە بێت لێ هین نابێت ئێستا ڕەنگە ئەی پرسیارێ بخاتە بێ بڵێ ئەی باشە کەی بەرەو ساتورێتی دووردەوردەڕاتەوە تۆزە مەوزوعی شیلەکە ینی ڕێک ئەگزاکتلی وەکو ئەوەی ئێمە تەطبیق ناکات لە سایانسە بەڵام ئەتوانین بەشێکی تێ بگەین بوون لە ڕمەزانانی ئێمە شیرینیە کڕین ئێواران یا شتێکە دایانێ یان لۆقمە قازیە کڕین سێرێکی دوو ڕۆژ سێ ڕۆژ لۆقمە قازیە دابنێ دوای دوو ڕۆژەکە کە یەکەوە لۆقمە قازیەکە خۆی هەستە شەکری وردە ئەکەی خۆی یەکەم ئێوارەت یان نەبوو شەکری وردەکە بەس لە دووەم ئێوارە سێم ئێوارە سێرێکی شەکری وردەیتە یا شیلەیەک بەجێ هەڵی لە ناو سەلاجەکە دوای دوو ڕۆژێتەوە سێرێکی شیلەکە وردە شەکر چۆتە بنەکەوە ئەمە بۆ ئەمە وردە سوپەر ساتورێتەکە دیسترب بووە بە جوڵاندن و بە گۆڕانکاری و بە سەرمایەکی زۆر و بەم شتانە چی لە هاتووە دیسترب بۆ وردە دەیە بەرەو چی بڕاتەوە ئێ بەرەو ساتورێتەکە بڕاتەوە وردە دەپرێس زیایەکەی کە هەیەی کە لە سوپەر ساتورێتیدا بووە وردە دەرەوە ئەنیشێت وردە بەرەو ساتورێت ئەڕوا ڕەنگە تۆزە بۆ ڕادێن بەرەو ساتورێتت نەتوانێت لە ساسە بێتە بە ساتورێت بەڵام هەنێ لە زیایەکانی هێنێتە دەرەوە منیش ئەمڕۆ کە دەرسەکانی ئەمڕۆ تەواو بوو لەگەڵ ڤیدیۆکە کە مامۆستا بۆی ئەدیتکردن و ڤیدیۆکە بۆ دانان من لینکێکتان بۆ نێرم لە هەر لینکێکی یوتیوبە ئەتوانە سێریکەن کە مەسەلەن چۆن سوپەر ساتورێت سۆڵشنێک حازر کراوە بە شێوەیەکی هەتا زۆر خێرا پرسپیت دەکات و کریستەڵایز دەکات بەس ئەوەنە ئەو کریستەڵایزیشنەکەی زۆرە کە بەشێکی زۆری ئەبێ بە سۆڵیت چکە زۆر ڕێژەکان تێکردە یەکسەر ئەبێ بەرەو ساتورێتی دەڕوا چونکە سۆڵشنەکە سوپەر ساتورێت. So if you don't have any questions, we are done for today's class. I will not take any more time from you. We are done here. Any questions, please? Have a nice day, everyone. Enjoy the rest of your day.